Hi students, welcome to Max Point of View. Today we are going to solve each and every previous year questions from the chapter Electromagnetism. Before watching this video, my suggestion is watch the concept video, theory solutions and some numericals of all the parts of electromagnetism, then come back to this. Then this video will be useful for you. Why? Because what is the advantage of watching previous year paper solutions? First thing, you will understand how the questions are different from the textbook questions. Second, the same question which is there in the board exam, how it can be twisted in different angles. So we are not just going to learn the solution. Okay, when you go for Google, if you search this question, you will definitely get the answer. But who will teach you there? Okay, they will give you just the answer, but they will not teach you. Here we are going to teach you, and we are going to take the same question and twist it how much ever it is possible, so that you will learn everything about that concept. So without wasting any time, we'll start with the first question. State two causes of energy loss in a transformer. We are not just going to learn the solution for this question. Actually, there are three types of energy losses in a transformer. What are the names? What are the causes? What are the prevention? If you learn all these three, then the same question can be twisted in many other ways. Correct? So all the type of questions based on this topic we are going to learn, and the answer for this solution also I am going to give, and we are going to learn the complete concept, so that whatever the question they can twist based on this topic, that is losses of energy in transformer, we can easily answer it. So first we'll learn the concept, then we'll go for the question. What are the three types of losses in a transformer? Copper loss, eddy current loss and hysteresis loss. First, we'll talk everything about copper loss. What is copper loss? Copper loss is nothing but the loss of energy in the form of heat. Loss of energy in the form of heat. So this is copper loss. Okay, then what is the cause for it? If the thickness of the wire is small, okay, where thickness of the wire is small, then the temperature will be more because the resistance is more. Okay, when the thickness is less, temperature will be more, so energy loss in the form of heat, okay, that we call it as copper loss. This is the cause. Then what is the prevention? Prevention is very simple. We have to use a thicker wires. Done. Copper loss is the easiest loss. Now we'll go for eddy current. So first, what is eddy current? So current inside the primary and secondary coil is called as eddy current. Eddy current. Now why we call it as loss? Why? Because we have to talk about primary and secondary. Primary and secondary we have currents. So and primary and secondary is made up of conductor, so there will be a loss of energy in the form of heat when it comes to primary and secondary. Okay, this is the cause of eddy current. How can we minimize it? So it is easily minimized by laminating the core. What is the core area? So the complete primary and secondary, we call it as core. So if we laminate it, so this eddy current loss can be avoided. So we spoke about copper loss and eddy current. Both are in the form of heat, correct? So copper loss is about the wires, number of turns in the primary and secondary. Eddy current is about the core, primary side and the secondary side. So on the primary side and the secondary side, the loss of energy in the form of heat is eddy current. The loss of energy in the form of heat in the number of turns is called as copper loss. This is the simple difference. Now we'll talk about hysteresis loss. So this is completely related to type of current we are using, that is AC current. Why we are not using DC current? That is a different question that we know the answer, correct? So whenever we use AC current in a core, okay, the primary and the secondary core. So it current moves front and backward, because in 1 second it moves 50 times front, 50 times back. So whenever it moves 50 times front, so it is magnetized, the core is magnetized. Whenever it goes back, it is demagnetized. Whenever we do that magnetization and demagnetization, the energy will be lost. This type of loss we call it as hysteresis loss. So how to prevent it? By using the soft iron as a core, So these are the three different losses: causes and prevention. Now we'll go for the question. State two causes of energy loss in a transformer. One, the loss of energy in the form of heat, that is copper loss. They are not asking you to mention the loss, correct? Mention the type of loss, so don't mention it. What are the, you can generalize the things. Loss of energy in the form of heat, that is because of copper loss and as well as the eddy current. So difference you should know between the eddy current and the copper loss. Then that is one answer. Second one, hysteresis loss in the core of the transformer. Hysteresis loss, we can write it directly. Hysteresis loss in the core of the transformer due to magnetization and demagnetization in each cycle. So hysteresis loss is because of magnetization and demagnetization. So that you have to mention. So answer for this question is done. How the same question can be twisted? So they can ask what are the three type of losses: copper loss, eddy current loss, and hysteresis loss. Then what they can ask, what are the causes of these three? Okay, that is what we are learning. Then what are the preventions of these three losses? So in this way, if you learn, then you know everything about this topic. Now we'll move on to 2018. A magnet kept at a center of two coils A and B is moved to and fro as shown in the figure. So this magnet will move like this, to and fro. Then two galvanometers shows deflection, correct? Because whenever the magnet moves, okay, there will be current produced in the circuit, correct? So this we have learnt in the concept video. Now the question is, state with a reason whether x is greater than y or x is lesser than y. What is x actually here? We have coil A, we have a galvanometer, so there will be a deflection, that deflection we call it as x. We have coil B and it is also has one deflection, that deflection we call it as y. So which coil, as coil A or coil B, has more deflection? That is their question. Is x is greater than y, the deflection in coil A is greater than y, or deflection in coil B greater than x? So this is what they are asking. Without thinking anything, the answer is very simple. Deflection of y is greater. Why? Because see the number of turns. We know whenever we talk about magnetism and electricity, okay, if we are passing electricity, okay, the magnetic field will be more when the number of turns will be more. Here we are providing magnetic field and it is generating electricity. Again, it depends upon number of turns. Which has more number of turns? See, 1, 2, 3, 4 number of turns here. 1, 2, 3, 4, 5, 6, 7, many number of turns. So deflection, more current will be produced in coil B, so deflection will be more in coil B. That is, answer for this question is x lesser than y. This is the answer. So few students, what they'll do, they'll write like this. Even though answer is correct, in the question they have given options: x greater than y or x lesser than y. So this is our answer, correct? So this is also correct, but it will cause some confusion for the person who is correcting your paper. Our next question, the diagram shows a coil wounded around U-shape soft iron bar AB. So AB is a soft iron bar and the coil is wounded around it. So these kind of questions we have solved in during the concept as well as the theory solution. Now also we'll learn it, but the method you should know. If you don't know the method how to solve this one, okay, here we are going to use the same method, then you will understand, because in the concept video I have teach you the complete method, when to hold it like that, when to hold it like this, when to hold it like this, and how to analyze the based on the type this one direction of current, how to analyze which is south and which is north. All those methods you should know. That's why before coming to previous year solutions of any chapter, okay, we are doing it chapter wise. right? Any chapter, you should know the concept, theory as well as the numerical. So we are going to learn how the textbook questions are different from the board exam questions and how the same question can be twisted and we can answer it. Now we'll go for the question. What is the polarity induced at ends A and B when the switch is pressed? See, this is the symbol for switch is pressed. We know if this arrow mark was not there, that means switch is open, so that it is a open circuit. Now they have mentioned switch is pressed, so it is a closed circuit. Once it is a closed circuit, current will start passing. Correct. See, keep on writing the direction of current. That will give us the hint which is south and which is north. Okay. So here current goes back and comes again front here, and see this wire, the last wire is on the top of the core. That is important. Sometimes it will be behind, okay, and sometimes the same wire will be top here, and this side it will come from back side. So all these things are important. Now anyhow it is on the front side, so it goes here, current goes for comes from the back side. See here, correct. This is important. So we have to draw the direction of current. This direction of current here is not important. The direction of current on the core, that is important. See here, this wire is on it, right? So here back side we don't care. On the core, these are the wires on the core, right? These directions are important. Once you write the direction, aramse we can answer the questions. So see here in the concept video, I have clearly taught you that if the direction of current on the core is important. On the core, okay, is towards right side, then it is south. If it is towards left side, it is north. That is what we have learnt in the concept video. This right side and left side, this only works for U-shaped magnet. So now anyhow it is right side, right? So here it is right side. So first question, A is south. See the B. See B. Here it is. Here also it is towards right. So both the ends of A and B as south direction. How it is possible? That is what we have learnt in concept video. Correct. So I'll teach you here also. Now first we'll finish up the questions. State one way to strengthen the magnetic field in the coil by increasing the value of current, by increasing the magnitude of current, or strengthening the current value. So by strengthening the current, or you can write by increasing the number of turns of the coil. See, this complete everything is one coil. In that one coil we are increasing the number of turns of the coil. So in that way also we can increase the strength of the magnet. Now the last question, what will be the polarities of end A and B if the direction of current is reversed in the circuit? That means what they are telling, if you make this as plus and this as minus, okay, what happens to the polarities? Then both the sides will be, A and B will become north. A will become north and B will also become north if you reverse the direction of current. This is what we have learnt in concept, the basic concepts of magnetism. If you change the direction of current, magnetic polarity will also changes. So these are the answers. Now few students will have the doubts, how can A and B both the sides will have same polarities? Is that possible? Yes, it is possible. Listen, assume you take a huge magnet, rectangular block of magnet. Now assume this side is north and this side is south. Okay, now what I'll do, I'll create a shape like this, exactly like this. Now both the sides are south and both the sides of north. Okay, and the top it will be north. This is how it is possible. Now we'll move on to 2019. state two ways to increase the speed of rotation of DC motor. So rotation of DC motor. In DC motor, what we require, okay, the rotation. What we are providing as electricity as well as the magnetism. Magnetic coil will be there and we are passing electricity, correct? So we are providing both. This you should know. Okay, if they change the question to AC generator, then the answer will be little different. So you have to focus whether it is DC motor or AC generator. When it comes to DC motor, we are providing both magnetic field as well as the electric field. So now the answers will be very simple. They are asking for 2, right? We'll go for 4. First, by strengthening the current, by passing more current. Second one, by increasing the number of turns of the coil. So it is not number of coils. Number of coils is wrong. Number of turns of the coils. So then thickness of the wire. If you increase the thickness of the wire, what happens? The resistance reduces. Yeah, okay. By increasing the thickness of the wire, resistance reduces. If resistance reduces, current increases. If current increases, rotation increases. Correct? Then thickness. Last one, by strengthening the magnetic field by using powerful magnets. So these are the 4 possible answers. So they are asking only 2. So we have, you can write any 2, but if they are asking 2, don't write more than 2, because if one is wrong, okay, in out of, assume they're looking for 2, you have written 4. You have written 4. Out of 4, 2 is correct, 2 is wrong. You will get 0 mark. Why? Because they are asking for 2. Why do you want to write extra and that should be wrong? So if they are asking for 2 ways, write 2 ways exactly, that is enough. Don't write extra, and if that extra is wrong, you will lose marks in physics. So keep that in mind. Be careful during the exam. Our next question, draw a neat label diagram of AC generator. Yes, I know few students are puzzled now. Okay, why? Because the diagram of AC generator they have asked. Yes, they have asked. So diagram of AC generator and diagram of DC motor can be asked for 4 marks. So labeled and neat and labeled diagram. Don't write it roughly. Okay, so this is how you can write. You practice it. Here there is no procedure. You have to start from the bottom or you have to start from the side. No, you can start from anywhere. Make sure the diagram looks neat and it has to be labeled. Our next question, the diagram below shows a magnetic needle kept just below the conductor AB. Conductor AB, a magnetic needle. Okay, or else you can think of magnetic compass. Okay. Next, which is kept in the north-south direction, that's okay. We care only about the direction of current. Using that, we can aramse find it. This is what we have learnt in concept video. Concept video, I have taught you properly how to hold the hand. Okay, right hand, okay, thumb rule. But using that, we are going to find it. Now, first, in which direction will the needle deflect when the key is closed? Now, see the key. This is the key, right? Now, this is open. When you close it, this is the way to show it whether it is closed or open. So now it is closed. So once it is closed, current flows here, current flows here, and current flows here. Where is the needle? Needle is here. So above it, the direction of current is important for us. We don't care about this one and this one. We care only about this direction. Okay, why? Because this is where the conductor is and below it we have the needle. Okay, if the needle was here, okay, assume the needle was here, then we care about the direction of current. Okay, this direction is important for us. If the needle is here, okay, here above or below, we care only about this direction. So where is the needle in that path, okay, above or below, the direction of current is important for us. Now we got to know this is important. Okay, now we will focus on which rule to apply to find the direction of magnetic field. To find the direction of magnetic field, right hand thumb rule, that's it. To find the direction of magnetic field. Okay, so here we have to find the direction of deflection of magnetic needle, right? That is nothing but to find the direction of magnetic field. So we have to use right hand thumb rule. Okay, how to use it? We have to use it like this, correct? See, in the concept video I have taught you whether we have to use it like this or like this. When the conductor is horizontal, see, this is horizontal conductor, this is vertical, but we are not focusing on here these direction, correct? We are focusing on this direction because the magnetic needle is just below this conductor, so this conductor is horizontal. When the conductor is horizontal, we have to hold it like this. Actually we have to hold it like this only, but it will be little confusing, so we'll go for this. When the conductor is horizontal, we have to hold it like this. Okay, when the conductor is vertical, we have to hold it like this. We have to fold it. Okay, if the conductor is horizontal, open it. If the conductor is vertical, close it. Okay, now anyhow the conductor is horizontal, we'll open it. Now your palm always has to be in front of you. What rule we are using actually? That is right hand thumb rule. Whenever we talk about direction of magnetic field, to find the direction of magnetic field, it is always right hand thumb rule. Keep that in mind. So this is right hand thumb rule. My right hand thumb we are using, so right hand thumb rule. Now we have to hold it like this, and we have to arrange it according to the direction of current. Direction of current is towards left, so see, so you should not turn like this. This is completely wrong, because your palm has to be always in front of your face, so you have to rotate it. See, for me, I will rotate it like this. Now this represents, the thumb represents direction of current. So this is the direction of current. Where is the magnetic field? Downwards. What is downwards? That is east. So answer for A is east. That's it. So if you know this much, that is answer. See, if you know the rule, within 10 seconds you can get the answer. Okay, why is the deflection is produced? Okay, very simple. On passing the current through the coil AB, wire AB, magnetic field is produced in the coil. That magnetic field, okay, magnetic field will be produced around the wire. This, okay, magnetic field will affect the alignment of this magnetic needle. This is the cause. Next, what will be the change in the direction if the magnetic needle is kept just above the conductor AB? Now see, now the magnetic needle is below, correct? Magnetic needle is below. When we keep this one above, what happens? Nothing will happen. Anyhow the current flows in the same direction, okay, and magnetic needle is kept here, see, like this. Now again the direction of magnetic field will be same. No, absolutely wrong. Why? Because whenever we talk about keeping the magnetic needle above the coil or above the conductor, it is like this. Okay, we are keeping it ulta. So when it is kept ulta, then the direction of magnetic field also be ulta. That is nothing but opposite. What is opposite of east? So B is the reason. Then C answer will be west. See, west. That's it. Now we understood this one. See, this is very much important. When the needle is kept above it, you're not going to keep it like that. Okay, we are going to keep it like this, inverted, then everything will be opposite. Next, name one device which works on this principle. Very simple. Wherever we have magnet inside a device, that is an example for these kind of things. One is loudspeaker. In loudspeaker we have a magnet, and in electric bell we have magnet, so it's an electromagnet. Then these are the examples. So see, they can ask one more question: which rule you have used to find the direction of magnetic field? That is right hand thumb rule. So in this way we have to understand all the questions. Our next question: when the current carrying conductor is placed in a magnetic field, current carrying conductor, so a conductor is there and a magnetic field is also there. Okay, we don't know which side. It experiences a mechanical force, correct? When a magnet is there and a current carrying conductor is there, a force will be generated. That is how DC motor works, correct? So what should be the angle between the magnetic field and the length of the conductor? That means, what is the angle between the magnetic field and the electric field? So that force experienced is 0. Okay, when the force will be 0, how we have to arrange it so that force should be 0? When these two, okay, when these two, magnetic field and electric field, are parallel. When they are parallel, So the force produced will be 0. Why? Because see the why they are not asking. Correct. The reason they are not asking that you should know. Why? Because whenever electric field and magnetic field are kept parallel to each other, force will be equal and opposite. Force will be equal and opposite. So the net force will be 0. So when it will be 0 when the magnetic field and electric field are parallel to each other. This you should know. When these two are parallel to each other, the force produced force, the generated force will be 0. If they ask reason, they will produce force, but it will be equal and opposite in direction. So the net force will be 0. You don't have to write the reason right now. Okay, they're asking how to arrange it. You write just parallel. Don't write the reason. If the reason is wrong, again something you will definitely make mistake. Okay, so you will lose complete marks. So don't write extra and lose marks. They are asking for arrangement. How we have arranged it? Parallel. That is done. The reason you should know. If they ask reason, then you write it. Okay. Next, when it will be maximum. Okay, when the force the generated force will be maximum when the angle between them are 90 degree. 90 degree, or you can write it as when they are perpendicular to each other. When they are perpendicular to each other, the force generated will be maximum. When they are parallel to each other, force will be 0. That's it. Our next question, the diagram below shows a loop of wire carrying current I. So this is the loop of wire carrying the current I. Okay. Now, what is the magnetic polarity of the loop that faces us? So that means whenever we stand here, when it faces us, okay, that means whenever we are standing here, okay, then what is the polarity of this magnet? We know whenever a current is passed through a wire, a magnetic field will be produced. Whenever a magnetic field is produced, it should have north pole and south pole. That polarity they are asking. Whenever we standing here, okay, in front of it, what is the polarity of this, okay, magnet produced in this coil? Very simple. The answer is south. The answer is south. I'll tell you why. Answer is south. Why? Because whenever a current is passing, the direction of current is important. See, the current passes here, current passes here. We are talking about the loop. So direction of current in the loop is important. So see the direction of current from battery. See, from always it starts from positive, right? If the battery polarities are changed, then again everything will be ulta. I'll teach you that also. Now from plus, so it enters here, it moves in this direction. Correct? What direction is this? Clockwise. If it is clockwise, then it will be south. Correct? Now what I'll do, first I will answer all the questions, then we'll go for different kinds of question in the same diagram. So with respect to the diagram, how can we increase the strength of magnetic field produced by this loop? Very simple, by increasing the current in the coil, by strengthening the current in the coil. Very simple. That's it. To increase the magnetic field, we have to pass more current. That's it. Now, okay, this is the answer is by strengthening the current in the coil. Now that is it. Now what happens if I change the polarity? So this plus is here, minus is here, and you are still standing in front of it. Okay, so when the loop is facing us, okay, now anyhow the positive is here, current will not move from here. Correct? Current will start moving from here. So we don't care about all these direction of current. We care about the direction of current in the loop. So it is anti-clockwise. So whenever you are standing in front of it, so when the loop is facing us, so now you see the direction of current where it is passing from. Here it is producing anti-clockwise. Anti-clockwise means the polarity of this magnet will be north in front of it. If you go back side, so what if they change the question? What is the magnetic polarity of the loop if it is not facing us? See, if it is facing us means, so according to this question, okay, this is, okay, we are standing like this. We are standing like this. So if it is not facing us means, so we are looking from the back side. okay, from the back side. The loop is here, I'm looking like this. So in this direction, if the current is passing in this direction, okay, in this way, from the back side you will see it as clockwise. So from the back side it is south. So now it is in front of us, so it is north for now. So according to this polarity, okay, now it is north if you are standing here. If you are standing behind, okay, the loop is here and I'm standing behind it, then we will see it as clockwise. From that direction, okay, it will be south. So two things are important. One, where is the current is passing from, whether it is moving towards right side or left side, that is one thing. Whether the coil is facing us or not, that is also important. So whenever you get small doubt, just go back and watch it, you will definitely understand. Our next question, the diagram below shows the core of a transformer and its input and output connection. Okay, state the material used for the core. See this complete part, see this side input, that is primary side, output, that is secondary side. Everything we considered as core. So the core is made up of what material? Soft iron, that is their question. Okay, state the material used for the core, that is soft iron. Okay, if it is not soft iron, then what kind of loss we can see in the transformer? That is hysteresis loss. See, in this way also you can create questions. In one of the questions we have learned the three types of losses, causes for them, and how to prevent them, correct? In that, so if it is not soft iron, then hysteresis loss will be there. Next, copy and complete the diagram of transformer by drawing the input and output coils. Very simple. This side we have more voltage, correct? This side we have more voltage, this side we have less voltage. So what type of transformer is this? Step down transformer. If it is a step down transformer, primary side the number of turns will be more and secondary side it will be less. That's it. So this is how you draw it. So draw it again, okay, copy it, and you have to see where we have more voltage, that side we should have number of turns should be more. Number of turns should be more. So here number of turns are less, but where we have number of turns are less, that side the wires will be thicker. That side the wires will be thicker. Keep that in mind. See where we have more voltage, that side number of turns should be more, correct? So this is step down transformer. So here the voltage is less, 44, here is voltage is 220. So here voltage is less, so number of turns are less. But see where we have less number of voltage, we have less number of turns. Where we have less number of turns, that side the wire should be thicker. That side the wire should be thicker. Why? Because okay, when it comes to transformer, the temperature is not constant. So Ohm's law will not work here. Ohm's law will not work here. That means when the temperature is constant, voltage is directly proportional to current. If the temperature is not constant, voltage is inversely proportional to current. So here we have less voltage. Okay, we will have more current. When the current is more, the resistance has to be reduced. In order to reduce the resistance, okay, in order to reduce the resistance, the secondary side in this type of transformer, the secondary side should have thicker wires in order to reduce the resistance. If the resistance is less, the loss of energy in the form of heat will be less. Our next question, draw a neat label diagram of DC motor. Write one use of DC motor. Very simple. See, they are asking you to draw the diagram and write its use. So this is for 4 marks. Keep that in mind. You have to practice how to draw DC motor and AC generator, both the diagrams. So that is there in the syllabus. Working is not there, but diagram parts and their functions are there, correct? Working is not there. So you need to practice how to draw AC generator and DC motor. Both the diagrams are important, and if they ask, they will ask for 4 marks. Now we'll move on to 2023. A copper conductor is placed over two stretched copper wires whose ends are connected to a DC supply as shown in the diagram. Very simple. Listen, there is a DC source. See, whenever they talk about cell, this is cell. If you add one more cell, it becomes a battery, correct? That's the basic of 9th standard. Okay, so whenever you have cell or battery, it is always DC source. See, this is the symbol for AC source. Okay, so this is DC source. From the positive, the current starts moving, correct? So this is the diagram. In that circuit, okay, in the wires, okay, above the wires, just above the wire, okay, we have kept a rod, thick copper conductor we have kept it. So now they have mentioned the direction of force, okay. Now see, we have a DC source, we have a rod. What is this AB? That will learn here. What should be the magnetic poles at the A and B lying on either side of the conductor to experience a force in the upward direction? The force is in upward direction. It is clearly mentioned A and B are the polarities of a magnet. So we have electricity, we have magnet field, correct, magnetic field, we have a magnet here, okay, and the force is experience. This is related to what rule? That is Fleming's left hand rule. This is very much important. If you know it is related to which rule, then you can easily answer. See, electric field is there, AB, they have clearly mentioned in the question, these are the magnetic field, okay. We don't know the polarity, that is what we need to find, which whether A is north or B is north, that is what we have to find. We have electric field, we have magnetic field, there is a force, that means it is related to Fleming's left hand rule. Now I have taught you in the concept video how to use Fleming's left hand rule. So see, FBI, this is force, B represents magnetic field, I represents current. So anyhow, always we have to align the forefinger, okay, according to the magnetic field. Where is the north, okay, there we have to align this one. But in this question, they are asking the polarities of magnet, so we cannot align this one. We have to align these two, okay, because these two directions are given. Current direction is towards right, so this middle finger is current direction. Where is the force? Force is towards up. See, for initially I held it like this, correct, direction in the direction of current, but force is towards me. But in the question they have given force is towards up, so align it according to that. Now see, the force is up, this is the direction of magnetic field, okay. See the forefinger is towards the board, that means this is north, If forefinger is towards us, okay, then this would have been south. Keep this in mind. See why it is getting difficult, because in all the questions they used to give magnetic field, correct. In using that we used to align everything. Now magnetic field they are asking, that's why it is little difficult, okay. So what we have to do, align everything according to that direction of current and direction of force. Now if it is towards board, then A will be north. So the first question, A is north. If A is north, B will be south. Done. What is the next question? Name the law used to find these polarities. Fleming's left hand rule. That's it. Our next question. The diagram below shows a cardboard on which iron fillings are kept. A wire bent in the form of loop is seen passing through the cardboard. See, this is the loop of wire. It is passing through the cardboard. It is below the cardboard. This is above the cardboard. And these circles, okay, once you pass the electricity, these iron fillings are formed the circles. These circles are iron fillings, okay. Now when the current flows through it, iron fillings arrange themselves in as shown in the figure. See, as shown in the figure, they have arranged it. Now we'll go for the question. State the polarities of the battery A and B. See, listen, this is A and B. Whenever they talk about polarities of battery, we have to think which is positive and which is negative. Whenever they talk about polarities of a magnet, we have to think which is north, which is south. So here many students will write north and south. Completely wrong. They are talking about battery. In battery, where is the north pole and where is the south pole? When it comes to battery, polarity means positive and negative. So we have to find which is positive and which is negative. Very simple. So this is, see, we are passing electricity. Because of electricity, magnetic field is produced. Because of magnetic field, these iron fillings are arranged themselves. So we have passed electricity, it has produced magnetic field. We have to find the direction. Using the direction of magnetic field, we have to find the direction, polarities of battery. So we are using right hand thumb rule. In previous question, magnet was there, current was there, force was there. That is why we used Fleming's left hand rule. Here we have only current. Because of current, magnetic field is produced, and we are not talking about force, because force will not be produced. Because to produce a force, we have to introduce one more magnet, correct? So here magnet is not there, only current is there. Because of current, magnetic field is produced. So using the direction of magnetic field, we have to find the polarities. So it is right hand thumb rule. See, now it is vertical. See, this side it is vertical, right? And this side is also vertical. When the wires are vertical, in one of the questions the wire were horizontal. Do you remember the question was the wire was horizontal, we have kept the needle. There we have used it like this because the wire was horizontal. Now see, the wire is vertical. See here, vertical, right? So we have to use it like this. Now in the given diagram, we'll assume the current is moving up. We'll assume, not conclude, we'll assume. If the current is moving up, we have to hold it like this. So this, okay, fingers represents direction of magnetic field. So it is towards right. See, it is towards right. So it is like this, correct? Whenever we held it like this, it was like this. So these fingers, these are okay, these all four fingers represents magnetic field. It is towards right. So exactly like this one, correct? So the current is moving upward direction. This is how you have to analyze. So if the current is going upward direction, it will come here and moves here, correct? So if it current is going up, so that is obviously coming from here. If it is going here now up, so it has to come here, here and here, right? So if current is coming, A will be positive, B will be negative. So polarity is A is positive. You have to write positive polarity in the word, okay, not in the short form. Okay, next, state the effect on magnetic field if an iron rod is held along the axis of the coil. Along the axis means at the center of the coil. If you place a iron rod, what happens to the magnetic field? What is the effect on magnetic field? Means what happens to magnetic field, whether it increases or decreases. Answer is very simple, it increases. Why? Because see, because of electricity we have a magnetic field. Whenever you introduce one more iron rod, this, because of this magnetic field, electromagnetic field, that iron rod will also convert it into magnet. Initially we have magnet, now one more magnet because of iron rod, then initial magnetic field plus new magnetic field, so magnetic field will be increased. So answer for this question, what is the effect on magnetic field? Magnetic field increases or magnetic strength increases. Then state one way to change the polarity of the coil. How can we change the polarities of the coil? Okay, so they are not talking about the battery. They are not talking about the changing the polarity of the battery. No, changing the polarities of the coil. See, from here it is moving. So this will become south and this will become north, correct? We have to tell them how to change the polarities of the coil by reversing the direction of current. By, okay, in C, this is the first one, by reversing the direction of current, by reversing the direction of current. Decrease the strength of the magnetic field around the coil. How can we decrease them? We know because of this coil, okay, battery and wire, we have a magnetic field, correct? How to decrease the strength of the magnetic field? How to increase it? Actually, by increasing the current. In the same way, to decrease the magnetic strength, we have to decrease the current value. That means we have to reduce the current. That's it. Now we'll move on to 2024. State two factors affecting the speed of rotation of coil in DC motor. This question we have learned earlier, correct? So that's why we are skipping. Answer is given here. Our next question. Below is the diagram of transformer. Okay, this is the diagram of transformer. Primary side, secondary side, number of turns here is more, Here it is less. Very important. Now identify the type of transformer. Very simple. If the primary side number of turns are more compared to the secondary side, so here we have more voltage, here we have less voltage. Less voltage means less number of turns, more voltage means more number of turns. So here we have more number of turns, so we have more voltage on the primary side. Secondary side we have less voltage, so we are giving more voltage and it is reducing the voltage, so it is step down transformer. Step down transformer. So answer for question A is step down transformer. Second, in this type of transformer, which of the wire is thicker, the primary or secondary? Give reason. So in this question, okay, the second sub question we have already learnt in one of the question. Correct. Where we have less voltage, there we have thicker wires. We have less voltage here, so we have thicker wires here. So answer for this question, in this type of transformer, which side is thicker, primary or secondary? Which side is thicker they are asking. Reason later. So now they are asking which side. So you have to go according to the question. So you have to write secondary side is the answer. Now give reason. So now we have to give reason. Why? Because secondary side, okay, so see, first I'll teach you the complete method, then I'll teach you how to answer. Okay, so where we have more voltage, there we have less current. According to Ohm's law, voltage is directly proportional to current, correct? So what I'm telling here, we have more voltage, that means it has less current. Do you think that is correct? Correct. When the Ohm's law works, when the temperature remains constant. When it comes to overhead lines and power transmission, transformers, all those areas, temperature will not be constant. So if the temperature is not constant, voltage is inversely proportional to current. So here we have more voltage, so less current. Okay, primary side, voltage is more, current is less. On the secondary side, voltage is less, current is more. This you should know. Okay, when we have high current, the resistance has to be low. So in order to reduce the resistance, we have thicker wire on the secondary side in this diagram. Okay, where we have less voltage, there we have thicker wires. Why thicker wires? Because on that side where we have less voltage, we have more current. So in order to reduce the resistance, okay, we have thicker wire. Why we have to reduce the resistance? If the resistance is more, the temperature will be more, right? In order to reduce the temperature, the wire has to be thicker. So now how to write the answer here? Okay, on the secondary side, okay, the wires has to be thicker because you have to start from because only, because you have already written secondary side as the answer. You can start from because in order to reduce the resistance, okay, in order to reduce the resistance and to reduce the loss of energy in the form of heat, the wires has to be thicker on the secondary side. That's it. Our next question, state one factor that affects the magnitude of induced current in AC generator. In AC generator, what we are producing? Current. So they are asking what are the factors that affects the generated current. Very simple, the magnet, okay, the magnet and number of turns. More the number of turns, more the current will be produced. More the powerful magnet we are using, more the electric current will be produced. So what are the factors? They are asking one factor, so always write one, by using powerful magnet or by using more number of turns. That's it, any one. So answer for that question is done. Second one, okay, this is diagram based question. This is very much important. Given below is a circuit to study the magnetic effect of electric current. ABCD is a cardboard. ABCD is a cardboard kept perpendicularly to the conductor XY. Conductor, that wire, it is kept perpendicularly. So the cardboard is like this. The wire is passing through the cardboard. Next, a magnetic compass is placed at the point P. See, at P it is placed. The magnetic compass P is placed here at the cardboard, and P1 and P2 are the positions of magnetic compass before and after. So before passing the current, the magnetic compass is like this upward direction. Now after passing the current, the magnetic deflection will be towards right. Magnetic deflection will be towards right. Then if that is the case, name the rule that is used to predict the direction of deflection of the magnetic compass. See, we are finding what direction of deflection of magnetic field or magnetic compass, correct? So that is right hand thumb rule. So listen, when to use Fleming's left hand rule, when electric current is there, magnet, an external magnet should be there and force should be generated, then Fleming's left hand rule. Here we are just passing current, because of that current magnetic field is produced, we are not introducing one more magnet, so it cannot be Fleming's left hand rule, so it is right hand thumb rule. Right hand thumb rule. What is the answer for this question? Right hand thumb rule. So answer for the first question, right hand thumb rule. So first one is done. Now state the direction of current in the conductor. State the direction of current in the conductor. So that means the direction of current is only not given. See here they have given DC supply. That means current can enter from top, okay, it can be from X to Y. If it is entering like this, it should be X to Y. If the current is coming from down part like this, okay, it will be Y to X. We have to find that. Okay, how to find that? Based on the deflection. The deflection is given. See, initially before passing the current, the direction of magnetic field is like this. Direction of magnetic field is like this. Now after passing the current, it has turned towards left. It has turned towards left. So where is the wire? Wire is vertical, correct? Wire is vertical. I have taught you that if the wire is vertical, okay, here we have kept the compass, right? So you should not think about this direction of current here. You have to think only about here. So now the wire, this wire we are talking about, correct? Why? Because compass is placed here. So in one of the questions, the needle was here. See, the wire was here, the needle was here, so that's why we took the wire as horizontal. If the wire is horizontal, we have to hold it like this, correct? If the wire is horizontal, we have to hold it like this. Now in this case, compass is here and the wire is vertical, so we have to hold the finger like this. We have to hold the finger like this. In first question only we got to know it is right hand thumb rule, so we have to hold it like this. Whenever, assume, first we will go for wrong method. We'll go for wrong method. Assume the current is going from Y to X. Current is going from Y to X. So Y to X. So this is the current. So if it is going from Y to X, we have to fold it. It is vertical, so we have to hold it like this. Now see, assume the current is moving from Y to X. So where is the direction? It is towards right. See this direction, this is these are the direction of magnetic field lines, correct? So this is moving towards right, but according to the question it is moving towards left. So current is definitely not moving from Y to X. If it is not moving from Y to X, then it should be X to Y. So this is how you should analyze. See, so assume, we'll go for, this is easy for us, right? Now we to hold, this is what we have learnt. So apply this method only. Assume the current is moving towards up. Okay, why I am holding like this? Why not like this? Why? Because if it is horizontal, if it is a horizontal conductor, we'll hold it like this. If it is a vertical conductor, we'll hold it like this. Now anyhow we are holding like this. This is the direction of current. Assume the current is moving from Y to X, like coming from here. So this is just a switch. Okay, if you put a dot, it becomes a closed circuit. Okay, assume the current is coming from here. Okay, this is plus side, okay, positive, and this side is negative. The current will flow from here. Now the current is moving up. So if it is moving up, see the direction of magnetic field, it is towards right, but according to the question it is towards left. So definitely it is not moving from Y to X. If not Y to X, then it will be X to Y. This is how we are finding. Then we have one more question. If the resistance is increased, then what will be the effect of magnetic lines of force around the conductor? So if the resistance is increased, what happens to magnetic field? Whether it decreases or increases, that we have to mention. See, first we need to understand like this. Magnetic field is directly proportional to current. If the current is increased, magnetic field also increases. How current and resistance are related? current is inversely proportional to resistance. So if resistance increases, according to the question, if resistance increases, current decreases. If current decreases, magnetic field also decreases. So answer for this question is decreases. That's it. Now we'll move on to 2025. Which of the two, alternating current or direct current, produces varying magnetic field when it flows through a conductor? Varying magnetic field. What do you mean by varying magnetic field? Magnetic field keep on changing. If I pass direct current, the direction is same. What is direct current? That means current flows in only one direction. So it produces constant magnetic field. It produces constant magnetic field. But what do we want? Varying magnetic field. For the varying magnetic field, we have to give AC current. Why? Because AC current, we know it flows in both the direction. If the direction is getting varied, so the magnetic field will also be varied. If I give a direct current, it passes in only one direction, so magnetic field will be constant. But we, in this question, we want varying magnetic field. If they are asking for varying magnetic field, answer is AC current. If they are asking you to find the constant magnetic field, answer will be direct current. Keep that in mind. Next, second sub question, state the frequency of the alternating current supply in India. This is a very direct question. 50 hertz. 50 hertz. See, in the exam, what happens while I was correcting the paper, this was the keyword they have given, 50 hertz. They have written 50. Instead of writing hertz, they have written volts. This question is for 1 mark, and you know, if unit is wrong, 1 mark you are going to lose. So always focus on the unit also. Whenever you are learning something, learn it properly. Units are very much important. Many students, even though they have written 50, they have written amperes, voltage, watt, all those things. So hertz is the frequency. They are looking for frequency, so unit will be hertz. That's it. Our next question, copper wire is wound around a steel bar FT. See, there is a steel bar FT, normal bar, that is FT, that is made up of steel, and copper is wounded around it. Current is allowed to pass through the coil. Current is allowed to pass through the coil for some time and the bar is removed. Once the current is passed for some time, the bar is removed. The bar is removed. This is the statement they have given. Now we'll go for the questions. Draw only the magnetic bar FT. We have to draw only the magnetic bar FT and mark its poles. Mark it poles. So to find it, you know, in the concept video, these kind of questions we have learnt it how to find which side of the pole is north and which side of the pole is south. Correct? See, now first thing is, where is the current moving from? It is moving from positive. Correct? So it is moving from here. So whenever it is moving here, we have to hold it like this. Why we have to hold it like this? This is the technique I have taught. Okay, the students who have watched the videos. Correct? So if you are new for this video, like previous year paper, I told you, if you have watched the concept video, then only these kind of questions will be useful. Because once you watch the concept video, you will have knowledge. That is what we are going to apply here, and we are going to learn how the textbook questions are different from board paper questions. See, these kind of questions are not there in the textbook, correct? In board paper. But if you have that knowledge, you can apply it here. See, now we have to find which is south and which is north, correct? So the first wire is on the bar. First wire is on the bar, so we have to hold it like this. The thumb represents north. So these techniques are important. That's why you watch that videos, concept theory and numericals, then come back here. So this side is north. So F, okay, F is north and T is south. Done. So you write it in full form. North, N-O-R-T-H, south. The first question is done. We have to name the polarity. Second one, trace two magnetic field lines of force around FT, clearly indicating the direction. We have to write the magnetic field lines. This we have learnt in 9th standard. Correct? Magnetic field lines, we know it always moves from north to south. Correct? We just have to write the magnetic field lines. So this is the bar, and we know this is north and this is south. So two lines we have to draw. Two lines, correct? Not each both the sides. You can write minimum of two lines they are asking. That's it. Why this is towards south? Because we know outside the magnet, so because of the current this became a magnet. Now it is producing number field lines. So now field lines will be towards south when it is outside the magnet. So these field lines are okay outside the magnet. So if you can draw this one also. So inside the magnet it is from south to north. So these kind of simple questions, if you know the knowledge, we can easily apply it here. Our next question, a copper rod PQ carrying a current is kept a magnetic field as shown in the figure. So listen, a copper rod is there and there is a current. Okay, current passing through the wires. See, the direction of current is important. Okay, from here it is moving here. Okay, next, magnetic fields are kept and there is a rod. Whenever an external magnetic field is there and external current is there, a force will be created. So this you should know, it is related to something. It's not definitely not a right hand thumb rule, so it should be something else. So that we'll find it out. So now the copper rod PQ will move towards C. They are giving you the statement. They are saying the copper rod is going to move towards C. Whether we have to say whether it is true or false. Very simple. So we know external magnetic field, current, a force will be generated. This is Fleming's left hand rule. How to use Fleming's left hand rule? First, always assign. See, FBI. F means force. That is what we are going to find. In which way? If the force is towards, see, if the force is pushing the rod this side, the rod will move towards C. If the force is pushing this one, rod that side towards right, the rod will move towards A. Correct? We don't know the direction of force. That is what we need to find. What is given? FBI, F force, B means magnetic field, the direction of magnetic field, the direction of current. Correct. Now see, where is the direction of magnetic field? Magnetic field, whether it is moving from here to here or here to here, it is always moves from north to south. That we know. Correct. Outside the magnet, it is always moves from north to south. So the direction of magnetic field is towards down. First, always assign the direction of magnetic field. See, like this. Like this. Now see, this is the direction of magnetic field. Correct. Now we'll have to focus on direction of current. Direction of current is towards left. See, according to the orientation of my left hand, this is the direction of current. That is also towards left. This is magnetic field is towards down. Both are correct. Where is the force now? Force is towards the observer. Towards the observer. See, if I hold it like this, this is towards the observer. Okay, if it is like this, this will be away from the observer. Correct. So if I am standing in front of the board, means observer is here. So if you get it like this, it is towards the observer. Observer is here towards the observer. If it is like this, it is away from the observer. Correct. Now we have to analyze whether C is the observer or A is the observer. See, if the current is here, okay, magnetic field here, where will be the observer standing? Observer will be here, right? So observer will be here. Why? Because magnetic field and current is on that side. So observer is here. So we got to know, okay, when you hold it like this force is towards the observer. Observer cannot be standing here. Correct. Okay, he has to stand here. He or she has to stand here only. So observer is here. We got to know force is towards the observer. So force is towards the observer. So this rod will move towards the C. Towards C. So option A. Okay, sub question A is true. That's it. So you should not write sub question okay, A is correct. All those things. They are asking true or false. You just write true or false. So understanding, whenever you get small doubt, just go back and rewatch it. You will definitely understand. Now we'll go for the second question. Name the law used to determine the direction of motion of PQ. We told PQ was moving towards the C. So which law we have used it? That is Fleming's left hand rule. So Fleming's left hand rule. That's it. Now we have one more sub question. What will be the effect of force experienced if the rod PQ is replaced by another copper rod of same length? Same length is the keyword, but greater cross-sectional area. Greater cross-sectional area means what? The same rod, same length is there, but the initial thickness is like this. Now the thickness is like this. Now the length is same, the cross section they have increased. So what happens to the force experienced? There will be no change. Why? Because the force experienced, okay, according to Fleming's left hand rule, the force experienced depends upon three things: I, B, L. Okay, I represents current, more the current more the force. B represents magnetic field, more the powerful magnet more the force will be produced. What is this L? L represents the length of the conductor. Here they have given same length. If all the three are not there in the question, they are not talking about the current, they are not talking about the magnetic field, they are saying length is also same, then they are saying greater cross sectional area, that means thickness. Thickness is not related to force. This is the formula. Okay, based on this formula numericals are not there, but logical questions like this they can be expected. Okay, so now according to the formula IBL, they have mentioned all the three. Okay, they are not talking about I and B, so you have to remove from the picture. They have said L is same, length is same, they are talking about area of cross section is increased. Area of cross section is not related to force, so answer for C remains same. In D they are asking for justification, that means write the reason. You can write the reason as the generated force is independent of area of cross section. That's it. Now we have solved all the questions from 2017 to 2025 when it comes to electromagnetism. In this way you have to learn concept, theory solution, numericals if we have, then previous year paper solution, that to chapter wise. From every chapter you have to learn like this. After this one, go for logical and application oriented questions. That is also there in the description box. Why? Because we have from the specimen papers and competency based papers released by ICSE, that is nothing but ICSE board, that is released by them only. We are taken questions, logical questions. Okay, we are going to train you. So if you learn in this way, you have 100% knowledge. Whatever the questions they give, you can easily answer it in the board exam. So always once you finish one chapter, concept, theory, solution, okay, and numericals, directly go to the previous year paper, then logical questions only for that chapter. In this way you have to learn for every chapter, then you will have 100% knowledge. Thank you.